Moment of inertia of a uniform thin stick. We are considering a stick. This is the stick of length L and mass M. An axis is passing through the midpoint and perpendicular to the length of the stick. We have to find moment of inertia. Moment of inertia of this stick about an axis passing through the midpoint. I is equal to integral. The length of the stick is from minus L by 2 to plus L by 2. So the integrating limit is minus L by 2 to plus L by 2. X square dm. Similar to our earlier expressions which we had discussed in the previous class, x is the distance from the axis and this distance is what is varying from minus L by 2 to plus L by 2, and dm is the mass per unit length into the mass at distance dx. That means at a distance dx, what is the length of the thin stick? M is the total mass, L is the total length. M by L will be mass per unit length into the small distance dx. If this is the dx, small distance dx. So at that small distance dx, the mass will be dm. And this is distance square. So when you integrate it, you can substitute for dm as m by L dx. So this will be integral minus L by 2 to plus L by 2 x square m by L dx. M by L is constant. You can take it outside. So it becomes integral minus L by 2 to plus L by 2 x square dx. When you integrate x square, you get x cube by 3. X cube by 3. And the limit is minus L by 2 to plus L by 2. You substitute the limits and simplify. 3 you can take outside. So you will get moment of inertia of the thin stick as ml square by 12. The next case, the same stick we are going to consider, but the axis we are going to shift from the midpoint to the one of the ends. So this is the end of the stick. Same mass m, length L. So here moment of inertia is about this axis. The distance from this axis you have to consider. So distance is varying from 0 to L. So the integral varies from 0 to L. Again, this very same formula we are applying. Only thing we are changing the limit. So you get m by L. Similar to what we have done here. M by L integral x square dx. The limit is changing. Limit is changing from 0 to L. You substitute your limits, you get ml square by 3. So that is the moment of inertia of a uniform thin stick for an axis at one of the end and perpendicular to its length. Similarly, you can try the example of a solid sphere. I want you to find out the moment of inertia of a solid sphere along an axis passing through its center. A solid sphere with axis passing through its center. What you can do is, you can imagine the solid to be of mass capital M, of radius capital R, and you can slice the sphere in the shape of small disc. Already we have found out what is the moment of inertia of the disc, and you can integrate, you can find out mass per unit volume of the solid. Then you can integrate the moment of inertia for a small disc, integrating so that you get the entire volume of the sphere. I want you to do it as an assignment and submit in the classroom.